Welcome everyone to Algebra 2, section 4.2. We're still on absolute value. This time we're solving equations. So the absolute value of a number is, like we briefly talked about last class, a number's distance from 0. And I briefly mentioned that distance can't be negative. Like you can't take negative steps away from something. You can't drive negative miles. Um, so even if you're driving away from something, you're still driving positive miles. If you put a car in reverse, you're still going positive miles. No matter what you do, you're moving positive distance. It's impossible to move negative distance, regardless of what you do. So we're going to have 4 steps to solving absolute value equations. One is we're going to isolate the absolute value. So just like before with squares, before we square rooted, we isolated or got by itself the squared term. This time we're going to isolate or get by itself the absolute value. Then you want to write 2 new equations. And I'll explain this, but you'll want one of them to be positive and one of them to be negative. So I'll put a plus minus. Then you solve each equation like we know how to. And the last step is to check the solutions. Because sometimes we can get a solution that doesn't actually work, which we'll call an extraneous solution really. All right, so number 1, solving graph. Isolate the absolute value. Well, the absolute value of x, that's already by itself because it's not like 2 times this or 3 plus it, it's just by itself. Then it says write 2 new equations, making sure one's positive, one negative. So how we do that is we say x equals 5, x equals negative 5. So the left side stays the same, you just drop the absolute value bars. And the right side, you make one positive version of 5 and one negative version of 5. And then we would solve the equation, step 3. They're both already solved. So then we would check our solutions by plugging them back in. So we'd say, hey, does the absolute value of 5 equal 5? Yep. Does the absolute value of negative 5 equal 5? Yes, it does. So then we graph. So let this line be 0 and go 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right. And we're going to do closed circles because it is equal to it. If you recall from last chapter, when we had the inequalities, an open circle was when it was not or equal to it, where a closed circle was when it was or equal to it. But this time there's going to be no like arrows or lines or anything like that. It's just going to be that circle because it's just equal to it. It's not like, hey, it also could be less or greater. So we can see our solutions are these 2 numbers and that's it. Letter B, we have a little more to do. So the absolute value is still already by itself x minus 3 because everything inside the absolute value has nothing outside with it. Then we make 2 equations. X minus 3 equals 7. X minus 3 equals negative 7. The left side stayed the same. The right side became a positive and a negative version. Now we solve these equations by adding 3 to both sides. So you get 10 by adding 3 to both sides on the left. On the right, add 3 to both sides, you get negative 4. So still assuming that this is 0, you would go 1, 2, 3, 4 to the left and make a closed circle because it's equal to it. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right and make a closed circle. And you want to check your solutions by saying, hey, 10 minus 3, does the absolute value of that equal 7? Yeah, the absolute value of 7 equals 7. And we say, okay, well, what about the absolute value of negative 4 minus 3? Does that equal 7? And that's the absolute value of negative 7, and negative 7 is 7 away from 0. So that checks out. All right, and here's that word extraneous I was talking about, where it means it's an extra solution. It says check your answers on a graphing calculator. We haven't learned to do that. We can just plug it back in. We know how to do that. So how we'll go about this is there's a little bit more math to do now. So we want the absolute value part to be isolated. The absolute value part is just what's in the bars. so the 5x minus 10. So that means what's with it that we need to get rid of is the 9 being multiplied and the 1 being added. Remember, we get rid of addition and subtraction first, so we'll subtract 1. So we'll have 9 times the absolute value of 5x minus 10 equals 45. Now we divide both sides by 9, and we get the absolute value of 5x minus 10 is equal to 5. Now the absolute value part is by itself, so we make two equations. 5x minus 10 equals 5, and 5x minus 10 equals negative 5. And now we solve these two equations like we normally would, just some two-steppers, where in each equation you add 10, you get 5x equals 15, and 5x equals 5. Then you divide by 5, get x equals 3, x equals 1. And we're not asked to graph it this time. So these are the answers. And if you want to, you could also write it like we've talked about before, where maybe you put like x equals 1 comma 3, like you write them together, least to greatest. That's also great. Either one is fine. And then checking solutions for extraneous solutions, so you plug it back in. So you'd say, hey, 9 times the absolute value of 5 times 1 minus 10 plus 1, does it equal 46? So we say, okay, 9 times the absolute value of 5 minus 10 plus 1. 5 minus 10 is 5, negative 5, which the absolute value of which is 5. So that'd be 45, 9 times the absolute value of negative 5, 9 times 5. And yeah, 45 plus 1 is 46, so that checks out. So we say, okay, well, let's check the other one. 9 times the absolute value of 5 times 3 minus 10 plus 1, does it equal 46? So then you say, well, 5 times 3 is 15, absolute value of 15 minus 10 plus 1, you're going to get absolute value of 5 plus 1. 9 times 5 is 45, so once again, 45 plus 1 does equal 46, so both answers checked out. So to recap our solving, we had to get the absolute value part by itself by first subtracting 1 and then dividing by 9. Then we're able to split it into two different equations, so we did just that, one positive 5 and one negative 5 on the right-hand side, where the left-hand side say unchanged. All right, I would love for you to try letter B on your own. On letter B, the absolute value part's already isolated, so go ahead and make your two equations. 2x plus 5 over 2 equals 6x. 2x plus 5 over 2 equals negative 6x. Both of these, as much as we love to get rid of the positive 5 first, we can't because it's part of the fraction, so we have to get rid of the 2 first by multiplying by 2 or 2 over 1. 2 is reduced. 2x plus 5 equals 12x. Same thing on the other side. Two is reduced. 2x plus 5 equals negative 12x. Now we have x's on the left and the right, so we want to get those all together, so I'm going to subtract 2x from each side and get 5 equals 10x and 5 equals negative 14x. Divide by 10 and get x equals 5 over 10, or 1/2. Divide by negative 14 and get x equals negative 5 over 14. The negative on top, bottom, out in front, doesn't matter. And that would be all. Now, if it makes more sense to you to finish solving one equation and then solve the other one, go ahead. If it makes more sense to you to kind of solve an orange step for both, green step for both, purple for both, then do it that way. Really, whatever makes the most sense for you is what I want you to do. And we haven't had any extraneous solutions so far. I'll talk about, see, we won't have any, it looks like in this lesson today of when we'd have them. So let me talk about when you would have one of those, okay? So you would have an extraneous solution if you end up getting absolute value equals a negative, okay? So a quick aside here, talking about, hey, when would you have it, okay? So I'm going to just put it off to some random spot. So if you want, you can write this down, or you can not write it down and just pay attention, and then write down kind of a summary somewhere. So if you were to have like, oh, I don't know, the absolute value of like 5x plus 2 equals, oh look, my AirPods are 20%, equals negative 8. That will produce an extraneous solution. The reason why is you can't be negative away from 0. If it was positive 8, you would be fine because you can be 8 away from 0. But you can't be negative 8 away from 0. So now that can change where maybe you have a negative 2 times that is equal to negative 8. Then the absolute value isn't equal to a negative because you would divide by negative 2 first, and you'd get the absolute value to equal a positive, so you'd be fine. But that would all change if instead you had this scenario. It was equal to a positive 8, and you divide by a negative 2. Now, once again, the absolute value would equal a negative number. So whenever absolute value equals a negative is when you'll have an extraneous solution. So it would be a good idea to take note of that. All right, I would suggest that you try out 3 on your own, or excuse me, letter C on your own. Okay, so I'm going to subtract 1 to start to get my absolute value by itself, and to get the absolute value of 3x minus 2 equal to 13. Now I'm going to split my equation. 3x minus 2 equals 13. 3x minus 2 equals negative 13. So now I have the positive and negative version, because I could be 13 from 0, and if I'm at negative 13, I'm also 13 from 0. Add 2, 3x equals 15. Add 2, 3x equals negative 11. Divide by 3, x is 5. Divide by 3, doesn't reduce, so x is negative 11 over 3. Last but not least for these 4, before we get on to the word problem, D. Once again, I'd encourage you to do it on your own. All right, so the absolute value is already by itself, so I'm going to go ahead and write my 2 equations. 1/2 y plus 4 equals 6. 1/2 y plus 4 equals negative 6. So subtract 4, 1/2 y equals 2. Subtract 4, 1/2 y equals negative 10. Both scenarios, multiply both sides by 2, or 2 over 1. Y equals 4. And on the other one, y equals negative 20. So those are the 2 answers. And if you were to plug these in, you notice, hey, they work just fine. You get the absolute value of negative 6 and the absolute value of positive 6, which both equal 6. All right, the real world application, bottom of a river. So we can see this river here, and we say, hey, it makes a V shape that can be modeled by the absolute value function, d of h for the height is equal to 1/5 times the absolute value of h minus 240 minus 48, where d is the depth of the river, the bottom of the river in feet, and h is the horizontal distance to the left-hand shore in feet. Oh, I said height. Should have been horizontal. My apologies. So a ship risks running aground if the bottom of its keel, aka the lowest point of the ship under the water, reaches down to the river bottom. That makes sense. You don't want your boat to hit the bottom of the river. Suppose you're the harbor master, so you're the person in charge of the river, and you want to place buoys so that way the boat knows where not to go, where the river bottom is 30 feet below the surface, so that way people are aware of, hey, probably don't go over here. And so how far from left-hand shore should we place the buoys? And we want buoys probably on both sides, so that way they know, hey, don't go too far either direction. So what we do is we say, okay, we want it to be where the depth is 30 feet below the surface. So we're going to take this equation here, and we're going to make the depth, so over here on the left side, negative 30, because that's 30 feet below negative the surface. So we're going to say negative 30 is equal to 1/5 times the absolute value of h minus 240 minus 48. And we're going to solve for the horizontal distance h. And we should get two answers, one for how far from on this side and one for this side. And they both tell us how far from the left. So we'll start solving for the absolute value to get this by itself. So I'll have to get rid of the 1/5 and the negative 48. So we'll first add 48 and get 18 equals 1/5 times the absolute value of h minus 240. Then we'll multiply by 5, or 5 over 1. 5 times 18 is 90. And those 5's reduce, and you're left with the absolute value of h minus 240. Now we're going to make two equations, one positive, one negative. And I'm going to go ahead and flip it around to the 90s on the right here. H minus 240 equals 90. H minus 240 equals negative 90. So in both scenarios, we'll add 240 to each side, and 90 plus 240 gives us 350 feet. Let me try that again. 330 feet from the left-hand side. And the other one would be 150 feet from the left. So that'd be in the picture right about here, and right about here is where it's telling us to put the buoys. And if we were to plug those numbers back in for h, for the horizontal distance from the left, we'd end up getting d, the depth, to be negative 30.